So chapter 4 of the year 1 pure course starts off with cubic graphs. Now, a cubic graph is a graph taken from the function of the form ax cubed plus bx squared plus cx plus d. So the lead power is 3, the degree is 3, that's a cubic equation producing a cubic graph. In general, a cubic graph will turn twice. It might look like that, or it might look like that. What we need to know is it going to go off in positive y in x direction, or is the positive x direction, is it going to go down? So is it going to go up, is it going to go down? Is it going to go up to heaven, is it going to go to hell? Has it been a very good cubic equation? It's been a very naughty cubic equation. So heaven or hell. So most of the time, if we put the x-axis in, it's going to cross at 3 points, so it's going to have 3 solutions. Doesn't always though. You might have one looking like that. They'll only cross once. It's going to have to cross at least once though. It's not going to be possible to have no solutions to a cubic. So let's go on to example 1. So example 1 asks us to sketch the graph of the equation y equals x take 2, 1 take x, 1 plus x. So it's in fact form already, but if you expanded it, you get x cubed. That would be its lead power. We're not going to expand it, we don't need to. Firstly, working out where it crosses the x-axis, that's when we solve solve the function to be equal to 0. So that's going to be equal to 0, 2, 1, and minus 1. So it's going to cross at minus 1, 1, and 2. But what we now need to work out is though, is it going to go up to heaven, or is it going to go to hell? You can do that in a number of ways. Firstly, if it's minus 1, 1, 2, we can see what's happening at 3. So if 3 is positive, or is 3 negative, and then we'll be able to tell. Or we can substitute in positive infinity. So I'll show you both methods just quickly. So firstly, if x equals 3, y equals 1 times minus 2 times 4. I don't need to know the value, I just need to know the fact it's negative, so it is going to go to hell. If x is positive infinity, then y would be equal to infinity take 2, still infinity, 1 take away infinity is minus infinity, infinity plus 1 is infinity. So again, I'm not interested in the fact's value, I'm interested in it's positive or negative. So I've got a positive times a negative, it's negative, so it goes off to hell. So in terms of sketching it, it's going to go through minus 1, 1, 2. Start up at hell, 2, 1, minus 1. Remember, it's a sketch, it doesn't have to be perfect. The natural thing to do is end up having the turning point on the y-axis, which is very unlikely to be true. If you want to work out the value where it crosses the y-axis, we just substitute x equals 0. So x equals 0, y equals minus 2 times 1 times 1, which is minus 2. Okay, let's look at B. I'll try and squeeze B in down here. Again, same things before, this time I want to sketch x plus 1, x plus 2. So that's going to have solutions across the x-axis at 0, minus 1, minus 2. Heaven or hell? Well, let's look what happens at a positive value, because we're going minus 2, minus 1, 0, so what's happening bigger than that? Next is, say, 3. 3 times 4 times 5 is positive, so this one's going off to heaven. Where's it cross the y-axis? When x is 0, it's going to be 0, so it's going to cross through the origin. We knew that anyway. So just putting those together. So it's going to go through the origin, minus 1, minus 2, go off to heaven, 0, minus 1, minus 2. A cubic. Okay, let's look at example 2. So, going to sketch the graph of y equals x take 1 squared, x plus 1. Well, if you wrote that in full, you wouldn't normally, but if we wrote it in full, so that's going to be 1, 1, minus 1. So it crosses the x-axis at 1 twice. Oh, it's a bit strange. and at -1. Well, the fact it crosses 1 twice means you've got a repeated root. That means it's going to touch the x-axis at 1. Heaven or hell? Well, when x is infinity, infinity take 1 infinity, infinity take 1 infinity, infinity plus 1 infinity, positive, 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 it's going to go off to heaven. Or -1, 1. So when x is, say, 3, so it's 2 times 2 times 4, it's positive, so it goes off to heaven. So let's just quickly sketch that then. So heaven touches at 1, crosses at -1. Where's it cross the y-axis? When x is 0, -1 times -1 times 1 is 1. And we don't know the turning points on the y-axis, it probably isn't, but it's natural to make it look like it does, just be careful with that. B, y equals x cubed minus 2x squared minus 3x. So this is a little bit harder because this one isn't in factor form. But you notice straight away you've got an x in all 3 terms, so we can bring x out. And then it should factorise. You'd expect it to anyway. X and x, it's got to times together to make that, add together to make that. So it's going to be -3 and +1. So it's going to cross the x-axis at 0, 3 and -1. It's going to go through the origin, so that's where it crosses the y-axis as well. So when x equals 4, say, 4 times 1 times 5 is positive, so we know it's going to go up to heaven. When x is positive infinity, positive infinity, positive infinity, positive infinity, positive times positive times positive, it's going to go to heaven. So, heaven, 3, 0, -1. Something like that. Let's just try and squeeze C in here. Y equals x minus 2 cubed. So this one, this one's going to be quite a weird one, but it's going to cross the x-axis 3 times at 2. So something weird's going to happen at 2. What about when x is positive infinity? Positive infinity cubed is positive, so it's going to go off to heaven. Right, so it's only going to turn once when x equals 2. So this one goes off to heaven, hits 2, wants to come back. No, it's going to carry on going the same way. Okay, and that's called like a point of inflection. So where does it cross the y-axis? Cross the y-axis when x is 0. -2 cubed is -8. So very good graph, that one. Okay. So crosses once, twice, 3 times. It just changed its mind again. That's like a repeated root. Example 3, try and put down here. This time we're going to sketch the graph of the equation. Y equals x take 1, x squared plus x plus 2. So when this is equal to 0, when it crosses the x-axis, crosses the x-axis at 1, and then we need to make that equal to 0 and try and solve it. Now it won't factorise. The way you can prove it doesn't factorise is if we do b squared minus 4ac, we're going to get 1 minus 4 times 1 times 2, which is -7, which is negative. If b squared minus 4ac is less than 0, there's no solutions. So what this tells us is that it crosses at once, and then it's going to turn again. It's going to cross at 1. It's also going to cross the y-axis when x is 0. So 0, 0, 2, minus 1 times 2 is 2. So it's going to cross the y-axis at -2. Cross the x-axis at 1. This again, strange graph, this one. So it's going to cross the y-axis at -2, cross the x-axis at 1. Like something like that. When x equals, say, bigger than that 2, you can have 1 times 4 6, 8, 8. So you know it's going to be positive, or when x is positive infinity, positive infinity, positive infinity, positive infinity. So you've got positive top, positive is positive, we know it goes off 10. It's going to look something like that. It's probably going to turn somewhere else, we just don't know though. We need to do more maths in order to work out other turning points, but those are the only times it's going to cross the axes. You can work out the other turning points by differentiating, but we're not at that part of the chapter yet. Okay, if you have a go at exercise 4A.